Okay everyone, today we're going to be learning about the application of infinite geometric series. Okay, let's start. So a ball bounces from a roof of height 4 meters and it returns to 90% of its previous height on each bounce. Find the total distance traveled by the ball until it stops. Okay, if you see there, I already drew the diagram of how the ball bounces up and down. Okay, so I stretch it horizontally so that we can see, or we can write over it, and we can make it more visual of the distance. Okay, and I also wrote the formula of infinite geometric series over there. Okay, so let's start. Yeah, so the ball it bounces from a roof. The height of the roof is 4 meters. Okay, so this is the ball there. Okay, it bounces, goes down, and from the height of 4 meters. Okay, so it's from down, and then it bounces up. When it goes up, it only travels 90% of its previous height, which is 4 meters. Okay, so when it goes up again, it only reaches 90%. 90% is 0.9. Okay, so we're gonna have 0.9 times 4 meters. It goes up 0.9 times 4 meters, and it goes down the same distance. So it's also going down with a distance of 0.9 times 4 meters. So I'm gonna write up 0.9 times 4, down is also 0.9 times 4. I hope you can see the writing, because I think I used the wrong color, but oh well, I've started. Okay, so it goes down 0.9 times 4 meters. Okay, then it bounces up for the second time. Okay, it is going to be 0.9 times 0.9 times 4 meters. Okay, so it's a 0.9 of the 0.9 times 4 meters. Okay, so I'm gonna squeeze. Yeah, 0.9 times 0.9 times 4 meters. It goes up, and it goes to go down in the same distance. So it's going down with the distance of 0.9 of 0.9 times 4 meters. Okay, so it goes down with the same distance as it goes up, and it's gonna bounce again, and the distance of it's going up is gonna be 0.9 times the 0.9 times 0.9 times 4 meters, and it's gonna go down in the same distance. I hope it makes sense. Yeah, so okay, we're gonna write it down. Okay, we're gonna write it down. So first, okay, I'm gonna change the color. So first, the distance of it going down is 4 meters. Okay, and then it goes up. Okay, it goes up, it goes up, bouncing is 0.9. Oh, okay, I'm gonna erase, sorry, my plus is not good. Yeah, so it's gonna be plus 0.9 times 4 meters. Okay, and it's gonna go down again with the same distance as it going up, so which is another 0.9 times 4 meters. Okay, so that's the going down after the first bounce. Then for the second bounce is going to go up in the distance 0.9 of is a times of 0.9 again times 4. Okay, and it's gonna go down in the same distance as how it goes up, which is 0.9 of 0.9 of 4. Okay, we're gonna do one more time. Yeah, so then after it bounces for the second time, it's gonna go up again for the third time, which is the distance gonna be the 0.9 of 0.9 times 0.9 times 4. That's going up. Then it's going to go down again with the same distance as it goes up, which is 0.9 times 0.9 times 0.9 times 4, and so on. Okay, now we're going to try to simplify what we wrote so that it doesn't get too messy. Okay, so let's simplify. Okay, let's simplify. So we have, okay, I'm gonna scroll my iPad up. It's gonna be 4 plus, okay, let's have a look. There's 2 of them. That 2 of 0.9 times 4. So we have 4 plus 2 times 0.9 times 4. Okay, and if you see, it's going to be 2 over twice the 0.9s. Okay, so it's going to be 2. Whoa, okay, I forgot the plus. Okay, I'm going to write the plus. Okay, plus 2 times 0.9 squared times 4. Okay, see the, okay, and then we see another one's going to be like twice the cube of 0.9. Okay, so plus twice times 0.9 cube times 4 plus and so on. So the ball is like bouncing until like multiple times. We don't know how many times it's bouncing. That's why we consider it as bouncing until like infinite. Okay, so now we see like what we've written there. So okay, so we have like those numbers, and we're going to try to simplify. Okay, we're going to try to simplify by multiplying the one that we can multiply, and then we're going to try to ditch out the common. Okay, so let's do this. Yeah, so we have that 4 there. We're going to leave it alone. The 4 is going to be, we're going to leave the 4 alone, and then it's going to be 8 times 0.9. Okay, and then plus another 8 times 0.9 squared. Okay, then plus 8 times 0.9 cube, plus so on. Okay, you got it? Okay, and if you see all of the numbers, that train of numbers that we wrote, we're going to try to ditch out the common. Yeah, let's ditch out the common. So ditching out the common is actually very useful. It's very handy. Okay, so I'm going to go, okay, 4 plus. Okay, see that? 4 plus, the common is 8. So 8, I'm going to ditch the 8 out. So I'm left with 0.9 plus 0.9 squared plus 0.9 cubed plus dot dot dot. Okay, you got it there? Okay, so everyone, if you see, okay, I'm gonna scroll my screen down again. Yeah, so you can see the formula there. Okay, so if you see there, there's a repetition of series with the ratio of 0.9. So this bit here, that. So if you see that the U1 is the first unit, the first unit which is U1 is 0.9, okay, and the ratio is also 0.9, and it's going on forever. Yeah, so there's a dot 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 there. So I can use the infinite geometric series formula which I wrote at the top. Okay, so let's put it in. So we have it. So okay, I'm going to scroll up again. Oh no, this is what I'm going to do. I'm going to copy paste so you can actually see what I'm going to be using. Okay, so copy. Okay, I'm going to paste it here. That I have it there. So I'm going to put it in the formula. So I have this bit here. It's going to be U1. The U1 is 0.9, okay, over, okay, 1 minus 0.9, which is 0.1, yeah? So if you use a calculator, the answer is going to, or if you don't want to use a calculator, the answer is going to be 9. Okay, so this bit here, okay, this long train here, the one that I'm highlighting, is a 9. Now we just have to put it together with the other numbers, yeah? So we have 4 plus, okay, 8 times 9, okay, which is going to be, is 4 plus 72, so it's going to be 76 meters. Okay, so when the ball is from 4 meters high and it goes down, it bounces up 90% of the way, it goes down again, 90% of the way, it goes down again, 90% of the way, until it stops. When it bounces on it until it stops, the whole distance of when the ball is bouncing up and down is going to be 76 meters. Okay, I hope this is useful, and I hope this is like cleared up. Okay, thank you for watching. Bye bye.